All right, geometry, I'm going to walk through 5 problems with you here off of our 12.5 worksheet. And this one is a pretty significant departure from what we had been doing so far in Chapter 12. Now we're doing something that you guys are going to see a lot next year in Algebra 2, which is trying to come up with the equation of circles and trying to figure out the relationship between the equation of a circle and the graph of a circle and how they're connected. And this is a real big theme in Algebra 2. You've done this in the past with linear equations, where you might have something like y is equal to 2x minus 5, and you come up with the series of points that satisfy that equation, which forms a line with things like slope and y-intercept. But what you're going to find in Algebra 2 is there are all sorts of families of graphs out there that occur when we get certain patterns that are realized within this. So the equation for a circle is messy here, guys. In our notes, we wrote this out as x minus h quantity squared plus y minus k quantity squared is equal to r squared. That's what we call standard form of the equation of a circle. And what's important here is that the ordered pair h, k, now those are the two numbers that are being subtracted from x and y. HK is always going to get you the center of your circle. And r, not r squared, but r by itself is going to be the radius of your circle. So let's talk about how to read that. So in problem number 1, we were given this equation right over here, and let me write that down. X plus 2 quantity squared plus y minus 2 quantity squared is equal to 1. Now, I got to remind you guys, as we look at the graph here, that red circle that's present right here, everybody, that's the answer. Okay, so I probably should have given this to you without that there, but let's talk about how they got it. The first thing they did is they tried to figure out the values of h and k in order to get the center here. So the center of our circle comes from the numbers that are being subtracted from x and from y. Now this is a little bit tricky to get used to here. The standard form equation is x minus h, and h is the number right here that's being subtracted from x. Now when we look at our equation, we don't have x minus anything, we have x plus 2, but we've got to think in terms of subtraction. Adding 2 is the same thing as subtracting negative 2. So our h value is actually negative 2. Now, when we go to look at our k value here, k is the value right here being subtracted from y. So as we look at this binomial here, the number being subtracted from y is 2. So this is something you guys are going to have to get used to. When you see a positive 2 right here, the center actually has a negative coordinate. And here, when you see a negative 2, that means that your k value is actually going to be positive. So the center of our circle is located at negative 2, positive 2, which means that from the origin, we would go 2 units left and then 2 units up, and that's how we would have located the center of our circle. Now the next thing we need to do is figure out the radius. And what we need to recognize is that this constant over here on the right hand side is r squared. And in this case, that number is 1. So we know that r squared would have a value of 1. Now we don't want r squared, we want just r. So this might not be the best example because you can get away with a significant mistake here. To get r, we would need to take the square root of r squared, and we would do the square root of the right side as well. Well, the square root of the square of r is just plain r, and the square root of 1 is 1. Okay, so that's how we came up with these two pieces of information. Now, back to the graph, the center was at negative 2, positive 2, and with a radius of 1, I would just tell you to go 1 unit from the center, north, south, east, and west, and then draw the circle that connects those 4 points there in the middle. So that's how they came up with that red circle here. We had to figure out the center, h and k, from the numbers that were subtracted from x and y, and then we found the radius by taking the square root of this number. Now don't be fooled. In this case, this number was a 1 and the radius was 1. They won't usually be the same. For example, if this number over here was a 49, the radius wouldn't be 49. The radius would be the square root of that number. Your radius would end up being 7. So the radius is always the square root of this number. It just so happened that in this one case, the square root of 1 ended up being 1, and so this one time they were the same, but usually they won't be. Okay, 2, 3, and 4 are very, very similar. Let's take a look at number 5. Now in number 5, the directions have flipped around. In number 1, they gave us the equation of the circle and asked us to come up with the graph. Now they've given you the graph and they're asking us to come up with the equation. So the two things we need to know here, just like we did in the last problem, what's the center of our circle? And what's the radius of our circle? So the center you can kind of eyeball if you look at this thing, guys. The center of that circle looks like it's located right here. And that ordered pair from the origin is 1, 2, 3, 4 units to the left, and then 1, 2, 3 units down. So our center is -4, -3. And the radius is the distance from the center to any point on that circle. Probably easier to measure that straight north or south or east or west. You don't want to have to do something like this and do the Pythagorean theorem on that. So that segment that I just drew right there is 3 units long. So now that we know our center and our radius, what we should realize we actually know, what we actually know is the values of the 3 variables. Dang it, that happened again. The 3 variables here that we needed to know in order to write the equation. So the center gives us the values of h and k. So we now know that h is equal to -4 and that k is equal to -3. And with a radius of 3, we know that r is 3. So with that in mind, let's go back to the standard form equation of a circle, which is x minus h quantity squared plus y minus k quantity squared is equal to r squared. Now, one concept that some of you probably picked up last year in Algebra 1, and hopefully everybody will get next year in Algebra 2, when you have an equation like this, the x and the y are kind of general variables right there that can be used to represent any ordered pair on the graph. We don't put values in for x and y when we're writing an equation. If you think back to linear equations from last year, like y is equal to 2x minus 5, you'll notice that the equation of a line contains an x and a y, and all you did is put values in for m and b. Well, right here, we're going to leave the x and the y alone, and we're going to come up with values for h and for k and for r. And lucky for us, that's exactly what we found here, the h and the k and the r, by reading that information out of the diagram. So here we go. H is -4. So this equation is going to begin, now be careful here, this is x minus your h value, which is -4. Now, as soon as you see that, you kind of grimace and you go, oh, that's not, supposed to look like that. Anytime you find yourself writing minus a negative, you guys know well enough by this point that we really should be writing that as x plus 4. Close it and square it. Plus, and let's move on now, this would be a y minus k. Well, k is -3, but rather than writing minus -3, we're going to change that to a plus 3. Close it and square it. Is equal to, be careful here, your radius now gets squared. So we had a radius of 3. Don't write this as 3 squared, guys. Let's go ahead and do the work on that. 3 squared is going to end up getting you 9. And this here then is the equation of that circle that was graphed there in blue. X plus 4 quantity squared plus y plus 3 quantity squared is equal to 9. And remember something we said a while ago, when your center has a negative value, it actually looks like a plus, a positive, within the equation of the circle. Same thing here, our y coordinate was negative, but that actually looked like a plus there. So that's something you'll see with some regularity, so hopefully you won't be surprised when that does pop up. Okay, the directions for number 9 are actually the same as they were for number 5. They want us to take this information right here and come up with the equation for it. Well, this is actually easier than what we did in number 5, because in 5, we had to look at the graph and figure out the center and the radius. Here, they've given you those directly. So what we know right now, guys, is that our h value in our center is -7. Our k value, also coming from the y coordinate now of the center, is -8, and that your radius is 5. So back to standard form of the circle, x minus h quantity squared plus y minus k quantity squared is equal to r squared. You guys have noticed for the last 3 chapters I've been telling you always start by writing out a formula. Now we fill in what we know. H is negative 7. So this is x, and it would have been minus negative 7, but that now once again becomes a plus 7. Close the quantity and square it. Plus, we're going to have a y, and instead of minus negative 8, we'll make that a plus 8. Close it and square it, equals, your radius is 5, but that radius needs to get squared, and we'll have a 25 over here on the right. And that's it for number 9, everybody. That's the equation of the circle with a center at negative 7, negative 8, and a radius of 5. Okay, same directions now, write the equation of the circle, but 13's different. We hadn't done one like this at all. Here, they've given you the value of the coordinates of the center. So just like before, we know that h here is 17, and we know that k is equal to 9. But the missing piece of information here is the radius. We need to figure that out, but that information was not given to us in 13 the way that it was in number 9. But what they've done instead is they've given us the coordinates of a point on the circle. Now there's a couple of different ways to handle this, and if you're watching somebody else's video or if another geometry teacher tried to explain to you how to do this, they might be doing it a different way. But I'm going to do it in a way that I feel is consistent with what I've been telling you guys all along, which is start with a formula. X minus h quantity squared plus y minus k quantity squared is equal to r squared. Fill in what we know, guys. We know the value of h is 17. So I'm going to put a 17 here for the h squared plus the k value is 9. So that's going to be a 9 there. Close it and square it. Okay, that's where we're at, equals, and we don't know what the radius is, so that's going to remain r for now. The important thing, though, and we haven't gotten a chance to play with this yet, is that these two numbers right here, 18 and 9, those are the x and y coordinates of a point that's located on the circle. You can use those temporarily to put in as values for this x right here and this y right here. So for a point on the circle, our x value is 18. So that's going to be 18 minus 17 quantity squared. The y value of the point on the circle is that 9 right there. So that's going to be 9 minus 9 quantity squared. And now what we have is an equation here with 4 values plugged in, x, h, y, and k, and only one unknown. So, with all that in mind, all right, let's see what we can do to clean this up. This actually works out really nicely. The 18 minus 17 is 1 squared, plus the 9 minus 9 is going to be 0 squared. That equals r squared. Well, boy, usually this will be more interesting, but for now, 1 squared is 1, 0 squared is 0, and that equals r squared. So 1 plus 0 is 1, which equals r squared. And we would now do the square root on the right and the square root on the left, and we'd end up with r is equal to 1. So where are we right now, guys? We know the value of h is 17, we know the value of k is 9, and we just found the value of r to be 1. So, I wish I left myself a little bit more room right here, but let me start a new slide right here. Let's go back to the equation of a circle here that we use all the time. So that is x minus h quantity squared plus y minus k quantity squared is equal to r squared. To write the equation of a circle, we needed to know the values of h and k and r. And we now do, guys. We know that h was 17, k was 9, r was 1. Let me write those down. H was 17, k was 9, and r was 1. So let's put them all together, and we're going to get x minus an h value of 17, close it, and square it, plus y minus a k value of 9, close it, and square it, equals our radius, r, which is 1, and don't forget to square it, which in this case is still just 1. And that, everybody, is the equation of the circle they presented to us here in problem number, where were we? Number 13. with a center at 17.9 and passing through the point 18.9. Okay, so that was number 13, and I think number 14 works kind of the same way. 15 is a weird one that I decided to give you just for fun. I'm not going to throw you anything this difficult on a test here, everybody, but let's see how we do on this one. They've given us here the endpoints of a diameter here are at 5, 6, and negative 15, negative 2. Now, certain things haven't changed. To come up with the equation of a circle, we need to know h, the x-coordinate of our center, we need to know k, which is the y-coordinate of our center, and we need to know r, which is our radius. And here's the really fun news, guys. We don't know any of those three things here. What they've done instead is given you the endpoints of a diameter. Now, I don't care about where these points are, but if I think about what's going on, there's a circle, and a circle has an infinite number of diameters, but every one of them passes through the center. So what they've done is they've given you the coordinates of this endpoint and this endpoint. We've got to come up with the coordinates of the center right here, and we've got to come up with the radius. That's a really bad R, but that's what that's supposed to be. Okay, so we need the center and we need the radius. Let's try that again. So how are we going to find the center? Well, what I'm hoping you see from the diagram right here is that the center is at the midpoint of your diameter. So the first thing we need to do is use the midpoint formula in order to come up with that center. And the midpoint formula, if you guys remember from way back in chapter 1, is the sum of your two x-coordinates, x1 plus x2 divided by 2. You're finding the average of the x's, a big comma in the middle, and then we do the same thing for your y-coordinates, y1 plus y2 all over 2. So that is what we need to do to find our center. So that's going to equal, here we go. Taking a look at these 2 points, the x-coordinates are 5 and negative 15. So I'm really adding. This is really 5 plus negative 15, but we just write that as 5 minus 15 all over 2. Comma, and now the same thing for the y's. We add the y-coordinates together, which are a 6 plus a negative 2, so that's a minus 2, and divide that all by 2 as well. So what do we get here, guys? 5 minus 15 is a negative 10 over 2, comma. 6 minus 2 is a 4 over 2, comma. And I'm running out of room here, but here we go. Negative 10 divided by 2 is negative 5. 4 divided by 2 is 2. So we just found the coordinates of our center, everybody, to be negative 5, 2. That's your h value. That's your k value. Negative 5 goes right there for h. 2 goes right there for k. So that's progress. Okay? Now at that point, it's probably easiest to treat this the way that we did the last problem. We now know h and we know k, and we know that there are actually 2 points here located on the circle. I'm going to deal with this one right here, 5, 6, not the one that has negatives in there, and we're going to try to find r. So to do that, let's write out the general equation again. X minus h, close it, quantity squared, plus y minus k, close it, quantity squared, is equal to r squared. For x and for y, we're going to use a point located on the circle, so those are going to be the numbers 5 and 6. So I'm going to put a 5 in here for x and a 6 in here for y. Okay, we don't know what r is. And how about h and k? Well, we found right here that h was negative 5, k was 2. So right here we would write x minus negative 5. That's going to come out as a plus 5. Close it and square it. Plus, and our y minus k, well, since k is 2, that's going to be a 6 minus 2. Close it and square it equals r squared. Okay, what do we have here, guys? 5 plus 5 is 10. Don't forget to square that to get 20. Nope, not that. To get 25. I'm sorry. Let's try that again. 5 plus 5 is 10. 10 squared is 100. There we go. And now on this side, 6 minus 2 is 4. 4 squared is going to get you 16. All that equals r squared. So let's combine those two like terms, and we get something weird here, guys. 116 equals r squared. And to find r, we would take the square root of both sides, but I'm actually going to stop right there. If you wanted to, you could go a step further and you'd end up with this ugly thing. R is equal to the square root of 116, which I think ends up being 2 times the square root of 29. That doesn't help us that much. This is actually the value R squared, what we need for the formula here. So we now know that R squared is 116. So one more time, guys, if I again go back to the equation, x minus h quantity squared plus y minus k quantity squared is equal to r squared, let's fill in what we know. We knew that the value of h right here was -5. So this now becomes x minus -5 or plus 5 squared. Plus, we've got a y minus k, and we knew that our value of k all along was 2. So that's a y minus 2, close it, and square it, equals, and here we go, guys, we don't really want r, we really want to know what's the value of r squared. That's why I left this right here. The value of r squared is 116. So that ugly number goes over here on the right side. And that equation right there, guys, as nasty as it is, used the values that we found correctly for h and k and r, and that's the equation we were looking for. X plus 5 quantity squared plus y minus 2 quantity squared is equal to 116. Okay, that last problem was a tough one. You've got one more like that to try on your own. Let's see how you do on that, guys. So good luck on that worksheet, and let me know if you have any questions.